Now, what we did next is introduce a concept called hidden Markov model. Okay, so then came the idea of hidden Markov model. Okay, so what is the idea of hidden Markov model? Hidden Markov model means the states are not directly observable. Okay, that is, they are hidden from you. That is why the term hidden Markov model is used. Okay, so the states are not directly observable, but you observe a related phenomenon. Okay, so a phenomenon or phenomena, whatever it is, right? So for example, in our case, I said sunny, right, and cloudy. These are the states: cloudy, rainy, right? These are the states, but they are not, they are hidden from you. You are not able to see. Okay, but you can observe the condition. So this is where I was saying somebody is deep inside, some saint who wants to only meditate and take away, get away from the world, right? No material things, only pure things, of higher enlightenment and so on, right? So he is deep inside somewhere in the cave. He cannot see the outside weather condition. Okay, but somebody comes and supplies him food or something, and so puts grass or something there. So there's an observed event which is related to whatever the weather conditions are. There has to be some relation, right? Then only I can predict, right? So this is observed something, some observed phenomena which has some relationship to the underlying weather condition, right? So he can observe the condition of grass here, right? And so we say the grass can be dryish or something, damp and soggy, let's say. So grass can be in only one of those four conditions. These are not states. These we are going to think of as the actual observations. We see them, okay? This is what has happened, okay? But the states are what we are interested in, that is hidden from you, that is actual weather condition. Now, here we are going to talk about probabilities of the sunny guy. Given it is sunny, what are the chances that the grass, when outside condition is sunny, what are the chances of it generating a dry grass? What are the chances of it generating a dryish grass? What are the chances of it drying a damp thing and a soggy? So this is basically what we call as observation probability. Given I am in sunny state, what is the probability of observing dry grass? Okay, so see, given sunny, it can be only, the grass can be only in one of these four conditions, right? So let us say this is 0.6, this is 0.3, 0.08 and 0.02 or something. Okay, so this is what we call, and this is we call a discrete Markov, because there are only discrete, I mean finite set of observations. So it can be in only one of these four kind of observations that you can have. Okay, so this is basically the what we call as BJOT, or the observation probability. Okay. So, there is one transition probability we saw. This is the transition probability, right? This is the transition probability we saw. And now we are going to see uh, the observation probability. Okay, so this is the observation probability. Okay, so now similarly, if it is in cloudy, it can happen to have some probability to be dry or dryish or damp or soggy. Similarly, when it's rainy, it can be dry, dryish, damp or soggy. So, again you will get some matrix. This will be called the observation probability matrix. Both of these together can be used to find out what is the weather condition. So, now in a hidden Markov model, the problem is slightly different. Okay. So, given that I am in cloudy state or something, given today is cloudy, and so there is observation also, and I observe, right. In a Markovian chain, I am just trying to predict, and I observe day 1 to be dry, grass. Grass I can observe, something that is observable, right. D2 happens to be dry, D3 happens to be damp, D4 happens to be dryish, and D5 happens to be soggy. If I observe this, okay, what underlying weather conditions, what are the underlying weather conditions that can best explain these observations? That is the way we have to look at it, right. So, if I observe today is cloudy and I observe the next 5 days the grass condition, okay. So, now my question is, what is the best weather condition that could have generated these observations? What are the best states or state sequence, we call it, sequence of states. Remember, what do states mean? States means the weather, right? I am assuming the weather is hidden from you. These are the states. They are hidden from you. The weather conditions are hidden from you. So, what are the state sequence or sequence of hidden states? That best explain the observation dry, this whole thing, damp, soggy, so on. Okay. So, that is the question we are asking. So, it is similar to this, but now what is happening is I cannot observe the state, right. So, what do I observe? So, I observe. So, remember, states are something that I cannot observe, sorry. So, let us say I am in the cloudy state as usual. Okay, I am starting at, it can be sunny or rainy, I am just taking always this cloudy. Then the weather conditions can be any one of these three, right. So, it can be S1 sunny or cloudy or rainy, and let us say D1, right. This is my hidden guy, but I also have observations D2, D3, D4, D5 and so on, right. So, what are my observations? The observations happen to be dry, I think. What have I observed there? Dry, damp, damp, dryish and soggy. Dry, damp, dryish, soggy. As before, I can, what will I do? As usual, I can draw these probabilities, right, very easily, correct. Similarly, I will be here, I will be here, I will be here on D2. Again, I will go here or here or here, or I will go here or here or here, or sorry, or here or here or here. I'll keep doing it, but that's not enough. This part is going to be accounted for by the transition probabilities. That part will be accounted for. But we also want to say that we are going to observe dry. So, what is the probability of being in this state and generating dryish? That also becomes important. What is the probability of being in the state and and generating this guy, or this state and generating this guy. So, we have to account for that also. So, there is one more probability we have to account for. So, that is why when we go from the ith to jth state, so I have reached the jth state. So, I have to look at what is the probability of the jth state generating the tth observation, the tth time of observation. Okay. So, this is always going to be multiplication of two things. So, it will be something like A12 going from first state to second state, B, because I am in the second state, B2 on the first day, right, multiplied like that. You have to find all paths, right. So, it will be A13 going to the third state, going to the probability of the third state generating the D1 observation, right. So, that is what we are going to keep for every one of them. There will be two data points that I have to do. One is a transition and one is the observation probability, right. Not only should I reach this sunny state, but what is the probability after I reach the sunny state that I generate dry. Not only should I reach the cloudy state, given that I am in the cloudy state, what is the probability through the observation probability that I will generate a dry. Both the probabilities now get multiplied. Okay. So, that is what we are going to do. So, it will be a sequence of multiplies of both the transition and the observation probabilities, and then I can find out which sequence. Again, we will be doing some kind of Viterbi only, but with the multiplication with the observation probability, and we will find out what is the best state sequence that can explain the data which we are observing. Okay. So, this is the basic principle of hidden Markov models. Okay. So, I will now revise what I said in terms of the hidden Markov model, right. So, this is what I was talking about, the hidden Markov model. And so, here are the observable states and these are the hidden states. These are conditions that you cannot see. Okay. In the real world also we will see a similar scenario. In speech itself you will start seeing it. So, that is why the whole idea of hidden Markov models came. What you observe here is the actual condition, and from that we want to find out the state sequence. Okay. So, we always need in the hidden Markov model two probabilities. One is the transition probability, the Markovian chain, the edges, how are they going to do, and given that I am in a particular state, given that I am in a weather condition, right, how probable is that weather condition generating the observation dry or the observation dryish or the observation damp or soggy. So, given that I am in a sunny state, right, how probable is it that I am dryish or dry or damp or soggy. Okay. So, this is like exactly the kind of thing, so, given that given that I am in the male population, right, how many people are, maybe there are only two conditions, bald and not bald, right. So, given that I am a woman, what is the probability of bald and not bald? Those two are going to be different. Now, given I am sunny, dry grass has a certain probability, dryish will have. So, similarly, given I am in cloudy, it will be different. So, I am assuming that given that I know whether it is a male or a female, given that I have come to that particular condition, then the observation is whether they are bald or not bald, right. And given I am women, bald or not bald, children not bald or not bald, like that, some conditions like that, right. So, observations are what you can see, and hidden is something that you cannot see. Okay. So, if the bald example I take, somebody says bald, two consecutive people are standing next to each other or something, I don't know. You have to worry about sequences here, but basically if I see bald, then I have to also say that the underlying, there are three possible kinds of conditions of humans, males, females or children, and then given that it's bald, how likely is it that it came from the male population or the female population or the children population, so on. Okay. So, that is the basic idea of observation probability. Okay. And so, basically in a hidden Markov model, there are two pieces of information: the weather condition, that is the transition from the previous day, the transition probability, and the condition of the grass today, right. Given that I am in state, a particular state, how am I generating that condition? So, this is the transiting from the previous state to the next state, or previous state to next day, given I am today in the condition of I am observing the grass to be dry, that is also going to be helping me out. Okay. So, again it is a question of only using Viterbi algorithm, but the Viterbi algorithm will get one additional multiply, the observation probability multiplication, right. So, I think we did this last class, and so there are this is a transition probability yesterday and today. So, that is a connection previous state and next state, and weather and observation. So, this is basically the transition probability, and basically you are going to get, this is the observation probability, this is the observation probability. So, you are separated out into some multiplication of observation probability, and these are the transition probabilities. But actually each one of them, so it is like probability of dry. So, if I start from the cloudy condition, I have to multiply first cloudy, rainy, given cloudy multiplied by, given I am in the rainy condition, what is the probability of generating dry grass. Similarly, since I have already come to rainy, the next day what is the probability of rainy, and given that I am given that I am in rainy, what is the probability of generating dry. Similarly, because I am already in rainy, if the next day is cloudy, probability of rainy given cloudy, this is the transition. And then given that I am in the cloudy state, what is the probability of generating a soggy grass, that is the observation. So, these are the transition, these are the observation probabilities. Okay. And this is again going to look at the max that we saw, we have seen multiple times. So, it is going to look at the max of this, not only of the max of this, it also has to look at the observation probability. So, now I am, the first state is, remember, sunny, right. Second state is always cloudy in whatever we are drawing, and third is rainy. So, what am I doing here? I am trying to find the max of this and multiplying by the observation probability 0.6, because I am in sunny and I am going to observe dry. The weather condition on the day was dry, I think, second one. So, it is 0.6, that is why it is 0.6. If it is cloudy, again these are the Viterbi, the different paths that are coming here, then I have to multiply the observation, but remember the observation continues to be dry, nothing has changed. But if I am in the cloudy, how probable is it to generate dry? So, if I am cloudy, how probable is it to generate dry? That is why you are multiplying by 0.25. Or I can come here with a max of all of this, the Viterbi algorithm. Now, I am in the rainy condition, but I still have to generate dry. So, given I am in the rainy, what is the probability of generating dry? Given rainy, what is the probability of generating dry? 0.05. So, that is why, unlike the non-hidden Markov model where only the maxes are coming, here one more probability will get multiplied to account for the observation. Again, for the next state, what happens? Now it is soggy, right. So, observing soggy becomes important, and so therefore, I will take the max of all of this guy, multiply by, given it is sunny, what is the probability of generating a soggy, that one I have to multiply here, the observation probability, and given it is sunny, it is very highly unlikely, that is why it is 0.05. Then given it is cloudy, it is 0.25, and given it is rainy, it's 0.5. So that's how you are getting the Viterbi algorithm with one additional thing, which is the multiplication by the observation probabilities. That's all. Okay. And then you retrace the back, because the max you try to find out. So you'll retrace, and so the weather condition that best explains dry, soggy is nothing but sunny, sunny, cloudy, rainy. So sunny, cloudy, rainy. This is sunny, this is cloudy, this is rainy. Okay.